Hi Bharat,
Hi, sir. Good morning.
good morning. So it is deployment phase you are doing
Yes, so I'll be doing
solution demo. Okay.
deployment solution demo on AI-based bank fraud detection.
Mm.
Um, so, yeah, in my previous stage of life cycle, probably I'll show the previous. Um, in my previous stage of life of AI life cycle, we have identified fraud problem, collected the data, prepared it, developed the machine learning model, and validated the model for performance, safety, and reliability. So now we have reached an important stage: deployment. Deployment means taking taking our validated AI model and placing or putting it into a real banking environment where it can analyze actual transactions and provide fraud risk decision in real time. So the main objective is not just to build a good AI model. The real objective is, can we make this model work safely, reliable, quickly in real world? So we'll talk about uh, the first slide. Um, yeah. Uh, Deployment. Like, this slide gives us the complete, um, um, I would say, the main message of deployment from validation model to real world impact. So this is the main concept of layer 5. um, you know we have the model that has already been trained and validated. But a model setting inside the deployment environment cannot protect the bank customer. So we need to move the model into actual banking infrastructure. So the deployment environment needs to be secure, scalable, reliable, real time, and trusted. So the model needs to connect with the banking channels such as card payment, online banking, funds transfer, digital channels. So wherever a transaction happens, the model, the deployed model, should be able to analyze it, generate a risk score. Based on the risk score, the bank can decide whether to approve, review, or block the transactions. For example, suppose I normally spend rupees 2,000 to 5,000. Suddenly my transaction, suddenly if I do a transaction about 2 lakhs from a new device and a different country, the deployed AI model will identify the unusual characteristics and then generate a high risk score based on which the transaction would be stopped or blocked for verification. So a validated model becomes a valuable only when it can operate safely and reliable in the real world. Yeah, we'll talk about uh, from validated model to production. So this slide explains the journey from validated model to a production service. Um, on the left, we have the validated model. The model has already been checked for performance, fairness, security, robust and secure, and approved for deployment. So now we need to prepare it for the production. The model is packaged and and uh, and packaged. for the reliable resources. Then it is integrated with banking system. It is exposed through APIs. So banking applications can send transactions to the model. So we also need scalable infrastructure because bank may process thousands or millions of transactions. So finally, we need health and drift monitoring. So the deployment is not simply clicking a button under deploy. Um, there will be several activities um, involved. So um, imagine a chef preparing a food. Cooking a food is not enough. So before serving it to the customers, probably the chef need to pack it properly, make sure it reaches the restaurant. You know, make sure there is a right temperature. Serve the food safely and monitor the quality. So similarly, the AI model needs to be packed, secured, connected, and monitored before it can serve to the real banking transactions. Um, we'll talk about deployment architecture. So this is one of the most important architecture slide. It shows the complete journey from customer transaction to the fraud decision. The process starts with the customer. The customer may perform card, online, UPI, or wallet funds transfer. The transactions enters the business application. For example, a customer uses the mobile banking to transfer about 75,000 rupees. So the transaction is sent through a secure API and event stream. So next comes feature processing. The system attracts the information such as uh, the transaction amount, location, device, customer history, transaction frequency, merchant information. So the feature are then sent to the deployment prod module. The model produces a risk score. Based on the risk score, the transaction is allowed. If it is a low risk score, it is allowed. But a medium risk score, that's where the AI model could send out authentication OTP to the customer. If it is a high risk score, that's where the transaction would block for verification purpose. So, yeah. So the the important point from this slide would be notice that the AI generates a high score, but the decision engine determines the business action. So the discretion is very important in this slide. So we'll move on to the next slide, which is model deployment pipeline. So this slide explains the deployment pipeline. We start with the approved model. The model has already been passed, validated. So step one, approved model. We have the confirmed we have confirmed that the model is suitable for deployment. Package model. We package the model, its dependency and metadata uh, and metadata and required components. So step three is deploy into the production. So we move on into the target environment. It could be cloud, on premises, or hybrid infrastructure. Fourth, configure services. So we configure APIs, resources, scalable, and integration. Fifth would be release to production. Automate test tests are performed uh, to make the to make everything is working correctly. Step 6, live and production ready. Now the model is available to process real-time transaction. So think think uh, think about installation of a mobile application. So first we build the application, then we package it, then we install into the phone, configure the permission, and test it. Finally, the user starts using it. So the model deployment follows a similar process, but in the banking, the requirements for security and reliability are much higher. So I'll move on to the next slide. Real time fraud detection flow. Um, so now we come to the actual real time fraud scenario. Imagine a customer initiates a transaction about um, about 75,000 to a new account. The transaction contains information such as amount, merchant, merchant or beneficiary, device, location. So the transaction is captured by the banking system. The data is securely sent to the fraud API. So that's the third step. So the deployed API model analyzes the transaction features extracted in real time. The model collects the risk score. The decision engine then decides what action should be taken. The entire process needs to be happened within milliseconds. So the real, so the probably imagine you're sending at you're standing at an ATM. You insert a card. You request for 20,000. The bank cannot say the bank cannot say the customer to stand for 10 minutes while our fraud team checks it. The decision has to happen almost immediately. So this is why the real time interface is critical. The strong uh, validation, AI validation, uh, is required here. So the objective is to detect fraud before the transaction becomes a financial loss. Risk score for banking decisions. This slide explains how the AI prediction becomes an actual banking action. The AI model doesn't simply say fraud or not fraud. Instead, it produces a risk score. For example, a low risk score is 0 to 30%. A transaction like normal, the bank can approve it. Medium risk, 31 to 70%. The transaction is somewhat suspicious. The bank may ask for additional verification or send it for a review. High risk score, 71 to 100%. The transaction has a high possibility of fraud. The bank can block it or generate an alert. For example, suppose a model gives a fraud risk score of 72%. The decision engine sees that it falls into the high risk category. The transaction will be blocked. The customer may receive a notification saying that this particular transaction is suspicious and it is prevented. So the slide makes a very important distinction. Um, AI predicts the risk. The decision, the business decision engine decides the action. So the bank. So this is how the bank protects the customer money. So well, I'll talk about banking system integration. So this slide explains how the deployment fraud detection service integrates with different banking systems. The bank has many channels. For example, mobile banking, internet banking, ATM network, card transaction, payment gateways. So uh, we don't we don't want every channel to have a complete different fraud model. Instead, we can provide a centralized fraud detection API. So different banking systems can securely send transaction information through this particular API. The same fraud protection capability will be then applied consistently across the channel. For example, suppose a customer makes a suspicious transaction through mobile banking in the morning, UPI transaction in the afternoon, card payment in the evening. The bank should ideally have consistent view on the customer risk. Centralize the integration helps provide that consistency and security. So we have the multiple security layer like authentication, authorization, encryption, audit logging. So we are not only integrating the model, we are integrating it securely. Now, production monitoring. Here, after deployment, our job does not ends. In fact, another important responsibility begins where where the um, real-time production is monitored. We need to continuously know whether our deployed AI service is healthy. The dashboard in this slide shows the important um, production metrics. For example, um, number of transactions processed, number of fraud transaction detected, model latency, false positive rate, model availability. And the slide shows 3.62 million transactions processed simultaneously, 24,817 fraud detection. So yeah, so these metrics helps the operation team understand whether the system is properly working or not. Example P95 latency. Latency means that about 95% of requests are processed within the measured response time. For a banking fraud system, latency is very important because customers should not experience significant delay. For example, if the model suddenly takes 2 seconds instead of milliseconds, the customer may experience transaction delay. So we need monitoring to detect this quickly. Um, Model and data drift in production. So this slide introduces a very important concept called drift. AI model learns from historical data, but customer behavior changes over time. The fraudsters also changes their techniques. So therefore, the data that the model sees today may be different from the data used when the model was trained. This is called data drift. There can also be a decline in model performance, which is monitored through model performance metrics. For example, suppose a model has a trained using transaction behavior from 2025. At that time, customer may mainly uses cards and uh, net banking. Later, customers started using UPI and mobile wallet much more. So the transaction pattern may change. The model may not perform as well as before. So this is why we need continuous monitor drift. The cycle shows here: detect, drift, investigate, collect new data, reframe, revalidate, redeploy. So this continues. This connects the layer 5 with layer 7 because deployment is part of continuous life cycle. Uh, this slide will talk about security and access control. An AI fraud model is itself a critical banking asset. So therefore, we need strong security around it. The first layer is authentication. We need to verify who is trying to access the system. For example, multi-factor authentication can be used. The second is the authorization. Even after some logs in, um, uh, they should also get the permission they need. For example, a fraud analyst can investigate case while a machine learning engineer can monitor the model performance. So the third is encryption. Sensitive information should be protected while moving through the network and while stored. Um, so if this actually gives people only access they actually need. For example, a person working in a fraud investigation does not necessarily need permission to change the production model. So other controls, we also have audit logging, uh, threat protection, data privacy, regulatory compliance, continuous monitoring, access governance, zero trust security. All these controls make the deployment secure. Fraud alert and incident management. So the flow was what we detect, alert, investigate, resolve, and learn. For example, a customer makes a transaction of 75,000. The model gives it 92% fraud risk score. The system generates a fraud alert. A case is automatically created. A fraud analyst receives the case. The analyst checks additional information such as customer history, device, location, transaction history, merchant, um, previous suspicious activity. So, based on the investigation, the bank can block the transaction, request additional verification, allow the transaction. In this example, the transaction is blocked. Human in the loop explains this is also an example of human oversight, and uh, an AI identifies a suspicious transactions quickly, but for certain cases, human analysts can investigate and take the appropriate actions. So this is important because AI should support human decision making, particularly for some complex cases. Learning after the case is closed, the outcome is recorded. What is actually fraud? What is false alarm? This kind of feedback can help improve the model. We'll talk about fraud detection in production. So this is the main demonstration slide for layer 5. Here we can see the complete production flow. The transaction enters the banking system. It is sent securely to the deployed fraud API. The AI model analyzes the transaction. The model looks at different features such as new device location, unusual transaction timing, high amount. The model generates 92% fraud risk score. The decision engine evaluates the risk. Because the risk is very high, the transaction is blocked. The fraud alert is created. The fraud operation teams receive the alert. The case is then assigned to okay fraud analyst who then evaluates the risk. Just for an example, let's imagine that I've done the transaction amount of 75,000 in uh, in location, maybe in Russia, with a new device. The risk score is 92%. The customer normally operates from India using new unknown devices. Suddenly, there is a high value transaction from a new device, which is from an unusual location. So the AI identifies the combination as high suspicious. The bank blocks the transaction, and the customer may the before the customer loses the money. AI detects in the real time. The bank can acts instantly. Fraud is stopped before the damage. Production monitoring. So this slide goes uh, one step further into the production monitoring. Once our fraud detection service is live, we continuously monitor several categories: model performance. We monitor metrics such as accuracy and recall, F1 score, ROC, AUC, precision. But we also need to monitor business KPIs, data quality, model health, API availability. We would also look at number of alerts, analyst actions, fraud prevented, customer impact, compliance, and audit. So we maintain record of decisions, access, and explain where required. So, for example, imagine a model was working at 95% performance. After a few months, the performance dropped significantly without monitoring. We may not notice, but the production monitoring, we get an alert, can investigate the reason. The complete AI fraud detection lifecycle. Uh, this final slide brings everything together. So layer 5 connects more model deployment and validation to actual layer um, operations. The the complete journey is right from problem, data, model, validation, deployment, production runtime, feedback, and learning. The deployment is the bridge between AI model created by the data scientist and the actual business value delivered to the client, to the customer. So, in our bank fraud detection example, that means taking a validated fraud model and making it available to protect real time customer transactions. So, here the key outcome is business impact, fraud, faster fraud detection, security, protect AI infrastructure, operational availability, continuous monitoring, human oversight, um, continuous improvement, feedback help improve the model. And so the final objective is trust, secure, real time fraud protection. To conclude, the AI deployment is not simply moving the model from one server to another. It is about making the model a trusted, secure, scalable, and monitored business services. In the in our bank fraud detection user case, mm, uh, I have successfully deployed means the that every transaction can be analyzed in the real time. Suspicious transactions can be stopped um, before the damage occurs, and the feedback from the production can continuously improve the AI tool. Uh, that comes the end of this presentation. So the
Okay.
layer, uh, so the layer 5 is about taking the validation fraud detection model from making it available to the real banking environment. All right,
Are you
that's all I
showing any
have, sir.
slide here?
No, 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 sir.
Nothing
It's
done,
just
right?
a
That is done.
conclusion point. Yes,
Yeah,
yes,
conclusion,
done.
right? Done. Let us
Yes.
stop recording.
Sure, sure. Thank you, sir.